Welcome, everyone. We are here to talk about the most critical gap in the modern technology. We live in a world where anyone can build a machine learning model. A student can do it in a Jupyter notebook in under 10 minutes, but very few companies can actually keep that model running in the real world without it crashing, degrading, or losing money. So, today we are talking about MLOps. This is the art and science of industrializing artificial intelligence. This is how we move from a messy science experiment to a reliable business engine. So why do we need this? Because right now most organizations look like this. On the left, you have data scientists. They are brilliant at math, they care about accuracy, but they work in chaotic notebooks. When they finish a model, they essentially throw a paper airplane of code over this wall. On the right, you have operations engineers. They don't care about the math, they care about keeping the servers from burning down. When the code lands on their desk, it's often incompatible, slow, or buggy. This wall of confusion is why 87% of AI projects fail to make it to production. It works on the scientist's laptop, but it breaks in the real world. So the solution is MLOps. Now MLOps is not a single tool, it's a culture. If you look at this diagram, it is the intersection of three distinct worlds: data science, the math and the models; data engineering, moving massive amounts of information efficiently; and DevOps, the automation and infrastructure. MLOps sits right in the center. It's the set of practices that allow us to deploy models reliably, efficiently, and at scale. So what does this look like in practice? We don't just use one software, we build a supply chain. First, data prep. We use tools like DVC to version our data just like we version code. Second, tracking. We use MLflow. If you don't track your experiments, you aren't doing science, you're just guessing. Third, orchestration. Tools like Kubeflow or Airflow automate those steps so humans don't have to click buttons manually. Fourth, serving. We use BentoML or Kserve to package the model into fast API. Finally, monitoring. We watch the model in the wild. Now, I want to highlight the last step, that is monitoring. This is the single biggest difference between regular software and AI. If you write a calculator app, 2 plus 2 will always be 4. The code doesn't rot. But in AI, models decay. We call this as data drift. The world changes. A model trained on shopper's behavior in summer will fail in winter. A model trained before a market crash fails after it. Without MLOps monitoring tools like Evidently AI, your model becomes dumber every single day without you even knowing it. So now we know data drifts and model decay. This is the challenge of today, but what about tomorrow? Where is the industry going in 2025? There are three massive trends reshaping MLOps right now. So the first trend is from chatbots to AgentOps. We are moving from models that predict to agents that act. So booking flights, writing code, monitoring an agent that takes action is much harder. So the second trend is the rise of SLMs, that is small language models. Not everyone needs massive GPTs like GPT-4. Companies are fine-tuning smaller, cheaper models to run locally on their own servers. The third trend is the automated guardrails. So we can no longer just vibe check output. We are using LLM as judge to automatically grade AI safety before user even sees it. As you can see, MLOps doesn't just happen in vacuum. As you scale, you start orbiting other major departments. You need FinOps because renting GPU is expensive and you need to control costs. You need SecOps because you cannot leak private user data into public model. You need platform engineering to build the self-serve infrastructure that supports it all. I know that this might sound like a lot. If you're just starting, do not panic. You don't need to climb the mountain in one jump. Start at level 1. At level 1, just master Linux, Python, and SQL. And at level 2, learn Docker. You cannot do MLOps if you don't understand containers. And at level 3, learn the cloud, that is AWS or Azure. And at level 4, pick up MLflow and start tracking your work. And at level 5, when you're ready with all these things, just tackle the beast, that is Kubernetes. So follow this path step by step. But for those of you who want to be in the top 1% of the engineers, this is where you have to go next. We're talking about GPU optimization, that is quantizing models to 4-bit to save 70% on compute costs. We're talking about Kubernetes operators who write custom code to manage your infrastructure automatically. And we are talking about RAG optimization, that is fine-tuning vector retrieval so your GenAI models stop hallucinating. These are hard skills that define the next generation of MLOps architects. So to wrap up, the goal isn't just to build a model in notebook that provides zero value. The goal is to build a system that can build, test, deploy, and monitor models automatically. That is MLOps.